I just got tired of watching it. No, he doesn't. They need to keep him quiet. All right, you said you sent some. I think I saw there. I saw your name this morning. There they are. All right, let's look at those. Do them in order. That one is 618. That one is 612. 612 comes first. All right, this is questions sent out of 6.1, 23/6. 23/6, that means it's like number 6. And that is a test, no, well, it could be a test question. What does the word say right here? Evaluate means what? Plug and what? Plug and chug. It means you're not going to use algebra, you're going to use what? Order of what? So wherever there's an X, I'm going to plug in a set of what? A big set of parentheses. Plus 4. And what are we going to plug in to the big set of parentheses? Say again? 2/3. And in fact, let's animate it a little bit. And use blue. 2/3. Now the first thing you want to do is parentheses or exponent, whichever one you want to call it. So 2/3 squared, what's 2 squared? 4. What's 3 squared? 9. Minus 5/1. 2/3. Plus 4/1. And what happens to the 4s? That leaves you as 1/9 minus 10/what? 3 plus 4/1. Now notice I'm making everything's fractions. Why am I making everything fractions? To make you mad? No, to tell you, either consciously or subconsciously, that you got to get a common denominator sometime. So what's the common denominator of 9, 3, and 1? 9. I'll put 9 here, 9 here, and 9 here. Negative and positive. How many times will 9 go into 9? 1 time. 1 times 1 is 1. How many times will 3 go into 9? 3 times 10. And how many times will 1 go into 9? 9 times 4 is... So we have 1 minus 30 plus 36 over 9. One minus 30 is what? Negative 29 plus 36 is what? Is it 7 or 5? 7? Whatever you say, I just... Negative 29 plus 6, 36, yeah. Over 9. Should be your answer. And that is a test question. You might as well go ahead and think you're going to get about 1 or 2 on those. Question. Right, complaint. Notice how I did the problem. What do you notice about the way I did it? Step by step, and I put everything where it needs to be. In other words, the first thing I did, every time I've told you, when you do evaluate or determine, wherever there's an X, you put in a big set of what? I get so many students. First thing I do, they say, I just can't do that problem, or they get mad. First thing I look at is the first step, and guess what they don't do? They don't put the big set of parentheses. And then if they don't do that, what do they mess up with then? They try to do everything in 2 steps, or less than 2 steps. That's the biggest problem I see with students that get these wrong. Now there's some that don't understand what to do, and I understand that. But the biggest 2 problems I see is 1, they don't put the big set of parentheses, and 2, they try to go from this step right here to this step right here in like 1 or 2 steps. Okay. Let me get there. Hold on. Please go away. Sorry. Okay, the other one, 60 or 80 and 79. So 79/15. All right, this says the time T in minutes needed for clothes hanging on a line outdoors to dry at a specific temperature depends on the humidity, which is true. Humidity, when the humidity is high, it takes like forever for clothes to dry. The time can be explained by this equation. T is equal to blah, 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 where H is the humidity expressed as a decimal number. Find the length of time required for clothing to dry if there is 90% humidity. So T is equal to 2h squared plus 80h plus 50. Can somebody tell me what this is? I'm sorry, I heard blah, blah, blah. Huh? I didn't hear you. Yes, plug numbers in. But what have we just studied? A what? Formula. This is 6.1, but this is actually 6.3 material. Plug and what? Like you said, plug and chug. So we got 0.9. H is equal to 0.90. Which means very high what? Dang old Hubert, dang old Myrtle Beach humidity. Okay? So, T is equal to, first thing I do is draw big sets of parentheses. 2 times parentheses squared plus 80 times parentheses plus 50. Now I'm going to plug in a 0.9 here and a 0.9 here. Now you may need your calculator, but what's 0.9 squared? 0.081? Y'all check me on the calculator. Plus 80 times 0.9 plus 50, and you can do this on the calculator. So somebody do 2 times 0.081, somebody give me that number.
What is it?
1.62.
1.62.
0.162.
2 times
Point 081.
1.62.
0.162 plus, well, 10% of 80.
That zero there, and that's not, I don't think that's right. So that 2 times 0.081.
Well, I asked y'all what 0.9 squared, and y'all said, I said 0.081. Y'all said,
0.8 is 8.
okay, 0.81. And 2 times 0.81 is 1.62. All right, now, 10% of 80 is 8. So 8 times 9 is 72. Okay, I think so, yeah. And 1.62 plus 72 plus 50, yeah, y'all do that in the calculator. What do you get?
Mm-hmm.
123.62. Understand? So what does that mean? It takes that daggum laundry minutes, 123 minutes, which is almost an hour and what? Hour and a half, Hubert. Yeah, that's right, class. Or 2 hours. 2 hours.
It is 2 hours.
Yeah, 2 hours, 3 minutes, 2 hours, 4 minutes, whatever, something like that. Takes it a while. Next question. This one is 6.180/16. 16 in the online homework. A football is kicked vertically upward from a height of 3 feet with initial speed of blah, blah, blah. Here is your formula. Describe the ball's height above the ground in t seconds after it was kicked. Use this formula to find the ball's height 3 seconds after it was kicked. All right, this is your formula. Time. T is always time. H is equal to negative 16t squared plus 55t.
Height is 3 plus 55t.
I'm turning it around where we can understand it. Plus 3, because that's the way you write it. I don't know why they write it like this. It just messes students up. A football is kicked vertically upward from a height of 3 feet. We don't care about that. With an initial speed of 55 feet per second. Okay. All of that. You know what all this tells you? All of this tells you that. So do you need any of this? No. Because that's all in there. Describes the ball's height after t what? T seconds. So after so many seconds, if you was to plug in, that's supposed to be a t right here. Yeah, after you plug in like 3 seconds or 4 seconds or whatever, that's what the height is what you're going to get.
So did you plug in 3 seconds?
Well, what does this say? You plug in 3 seconds, so that'd be h is equal to negative 16 parentheses squared plus 55 parentheses plus 3. Then plug in 3. The reason I'm dotting it in is because that's what we're given. Don't get it confused with this 3 right here. That dotted in 3 comes from right here. This 3 comes from the 3 foot height. So don't get those confused. So h is equal to negative 16 times 9, plus 55 times 3 plus 3. H is equal to negative 16 times 9 is negative what? 144? Y'all check me. Plus 165 plus 3. Somebody check my math. And then negative 144 plus 65, 21, which is 24. So at 3 seconds, that football is at 24 feet.
Wouldn't matter if I did not.
As long as you keep the sign in front of it, it doesn't matter. So this negative 16t, I'll put it right here. The positive 5t goes right here. And then this is a plus in front of that 3, because if it was negative, it would be a negative. Those are 3 questions that could come from 6.1 or 6.3. You see what I'm saying? Because that's basically formulas. Except in 6.1, they call it equations, because they haven't told you about formulas yet. Okay? So those are 3 good questions. They could be a test question from 6.1 or 6.3. Now, what I'm going to cover today is, well, let me get rid of this. I'm going to go into inequalities. I think that's probably the next section that we talk about. What chapter is this? I can't remember. 6, and I think we're on 6.4, right? Yeah, because 6.5 or 6.5 is inequalities. We'll just go ahead and open this slide. One of the 2. I can't remember which one's which. Variation. Not going to go. Okay, we'll go over variation. I don't like variation, but we'll go over it. Before we go over it, I want to do something else. All right. Let's say I give you a recipe, and that recipe makes 12 cookies. Everybody with me? Everybody awake? All right. 2 eggs, 3 cups of milk, 1 cup of sugar, 1 stick of butter, 1 cup of flour. And I say that that makes 12 cookies, and I give you the dimensions of the cookies or whatever, and then make 12 cookies. Then what do I do if I want to make 24 cookies? Well, to get the multiplier, which is 2, I divide 24 by what? 2, or 12, sorry. 24 by 12. Because this is the number that I want, and this is the number that the recipe what? Makes. Okay? So if I want to make 36, then I got to multiply everything by what? 3. If I want to make 48, 48 divided by 12 is what? 4. Then I multiply everything by 4. But what if I want to make 75 cookies? Then you just don't do it. You multiply whatever the closest thing you know. You take 75 and you divide it by 12. Somebody take the calculator and divide by 12. What do you get?
6.25.
So I multiply all my ingredients by what? 6.2 or 6.3. Now I know theoretically you don't do that. I know that. You probably multiply by 7 and just eat the cookies that you don't above 75, right? You just do 7 and you say, okay, I'll eat the ones that I don't need. All right. The whole point is all of these all of these numbers right here, all of these numbers are what we call multipliers. Now you're used to using them because some of you might, be cooks and chefs and all that. But you have to have a multiplier to multiply by if you're going to extend your cookie making by a recipe that just makes 12. You've got to multiply. And if it comes out to be a decimal, you multiply by that decimal. Does everybody understand that? Everybody understand the whole 2 times 3 times, everybody understand that? All of this next section is based on multiplier. Okay? And that multiplier is called K. Alright? So I just wanted to go through this little spiel because now you're understanding what the multiplier is. The multiplier is a number that you multiply to make the ingredients for the cookies that you want. If you want 48 cookies, the multiplier is 4. If you want 2 dozen cookies, the multiplier is 2. Yes. In other words, how do you get that number? Well, you do 48 over 12. It's a ratio. 48 over 12 is the number that you want over the number that the recipe what? Makes. And that's how you get that number. What? Yeah, so you multiply, instead of 2 eggs, you put how many eggs? And 6 eggs, and here it'd be 8 eggs, and here it'd be 12.4 eggs, which is 12.5 eggs. See what I'm saying? Nobody's going to multiply by 6.2. You're going to multiply by 7, and then you're going to make 75 cookies and eat the rest. Okay? So that's, I'm just showing you all these that are highlighted in yellow. These are multipliers. They're called constants that you multiply by. Now, the reason I show you this is because in this section, which is 6 point whatever, let me pull it back up. Oh, gosh. There it is, 6.4. We're going to be studying variation. And variation is using K. Now there's several different types of variation. Hold on a second, I'll get to where I'm at. There's K, okay? Write that down. This is called direct variation. So write down the word direct variation and then put out to the side, y is equal to K times X. Now, what if you have inverse variation? I'm not going to do that yet. Come on. Inverse variation is that. And then joint variation is that. So the three main variations that we're going to talk about is direct, inverse, and joint variation. Now there's 3 types of formulas. I don't teach like the book teaches, so You just bear with me, because I don't want to just show you a problem and do it. I want to show you what kind of problems you're going to have and go from there. Now, there's 3 or 4 different type problems you're going to have with these variations. 1, you're going to be given K, X, Y, and Z. You're going to be given different variables, plug and chug. In other words, they're going to say Y is equal to K times X, and X is equal to 20. And what are you going to do with X is equal to 20 and K is equal to 5? What are you going to do with those two numbers? Plug and chug. So the simplest problem that you're going to get with these problems is plug and chug. So Y is equal to K is 5 and 20, and K times Y is equal to 100. Okay, that's the simplest question that you'll get in 6.4. The second type question you're going to get find K. Now finding K you've already done. We found out multiply by 2, multiply by 4, multiply by 5, multiply by 6, whatever the case may be. Once you find the K, that's your multiplier. So in those recipe questions, K came out to be 2, came out to be 3, came out to be 4, depending on what we needed. In this case, they're going to give you the numbers. They're going to say Y is equal to K times X. Y is equal to 100 and X is equal to 4. Now what are you going to do? Well, you can either plug and chug and solve for K, or you can solve for K and plug and chug. Doesn't matter. So I'm going to plug and chug. Y is 100 is equal to K times what? 4. How do I get rid of multiplying by 4? So K is equal to what? 25. Now, the difference between these two type questions is 2 is going to have an A, and it's going to have a B. And now it's going to ask for the formula for this inverse variation, for this direct variation. And what are you going to do with K? You're going to plug it back into the original and write the formula. So what's the original, what's the equation? Y is equal to what? 25 times what? 25 times X. So that's the second type question you're going to get. What's the third type question you're going to get? Well, the third type question encompasses 1 and 2 and then adds a little bit more to it. The third type question, it asks you to find K. That's A. Then it asks for the equation. That's B. And then it gives you more info. Okay? So Y is equal to K times X. Y is equal to 10. X is equal to 5. So what do? Plug and chug, Hubert. 10 is equal to K times 5, divide by 5. K is equal to what? 2. And what do we do in the second type problem? That's A. What do we do with B? Plug K back into the original. Y is equal to 2 times K. I'm sorry, not 2 times K. 2 times X. And then C, they're going to say X is equal to 25. And what do you think you'll do with that 25 now? Plug it in. So that'd be Y is equal to 2 times 25, and Y is equal to what? And that's the 3 type questions you're going to get in 6.4. 10% of the questions I give you are going to come from the first one. 40% are going to come from the second one, and 40 to 50% are going to come from the third one. So you need to focus on number 2 and number 3. You need to focus on this one and this one. Is that because I don't like y'all, or because I want you to learn something? Y'all just not going to talk to me today, is that it? Okay, that's fine. I just won't explain anything to y'all. How about that? Is that okay with y'all? Well, I would like to have interaction if that's possible with y'all. All right, so here we go. Now, there's a couple more things I want to mention before we get to a problem. And this is all I want to mention. How do you do these problems when you're setting them up? Now, I've already showed you what kind of problems you're going to have. This is how you set them up. 1, which variation? Right now, there's only 3 to choose from. 1, 2, and 3. Direct, inverse, or joint. So first you find out which formula. 2. Change variables. Is every single question going to say y x varies directly as y? No. They may use different letters. Which way do we read? Left to right. So the first letter that comes in the paragraph is going to be interchanged with what? Y. Y is equal to K times X. The second letter will interact with X. But what about K? K never what? Changes. K stays K unless you plug something in for it. It does not change to another variable. The only letters that change to a variable, a different variable, is Y, X, and Z, if they give you Z, or W, or something else. K does not change. And then, of course, 4, do whatever they ask you. In other words, one of those 3 problems one of those 3 types of problems I just asked you. Now you're going to see it in the first couple. You'll see what I'm talking about. So don't spaz or anything. Let's go ahead and look at this first example. All right, I want you to look at it. All right, so I want you to take a minute. I've got to sit down the hallway here. Write that problem. Find the equation, plug and chug, and see what you come up with. Now, the length that a spring will stretch, S, varies what? So we're going to use y is equal to what? Y is equal to k times x. Y is equal to k times x. What comes first in this sentence? The length that a spring will stretch, what? S goes with the y. K never what? Never changes. And what's the other letter? So F is x. There's your equation, or your formula. So all of this is done. Write the equation for the length that a spring will stretch if the constant of the proportionality, if the constant, what I tell you the constant was? Okay, so plug in 0.07 for K. S is equal to 0.07. Now this is a basic, it's a slide, okay? It's a teaching slide. It's not a homework problem, okay? This is showing you that all they want is remember me telling you to put K back into the original equation, like on number 2? Well, they're asking you to do it with this first equation. But they don't tell you to solve for K and give you other, they'll ask you to do that too. So this is pretty basic. Question. That's pretty simple. Y'all just not talking today. Why is that? Don't feel like talking much, Hubert. Oh, okay. Well, I appreciate the interaction, though. It always helps for a 5 or 6 hour constant period of teaching. It helps to have some interaction. I'm teaching from 8 o'clock in the morning to 2:30 in the afternoon. It helps to have students interact with you. So thank you. I appreciate it. Y'all suck. Y'all know that? I think y'all actually do it on purpose, not to talk to me. Is that what you do? Okay, look at this one. The area of a picture projected on a movie screen varies what? Directly. Y is equal to K times X. Oh, why do they do this? See, I don't teach like this. They throw that D in there, and it's not time to throw the D in there. Okay, I'll go ahead and tell you what to do on this one because I don't agree with the way they're teaching it. That's why they've got people filling the classes because they throw stuff in too quick. Varies directly as the square of the distance. Now I want you to highlight that. Go ahead and write this down. Now take the highlighter out. And the square of the distance, D, when you see that, the square of the distance, H, the square of the distance, Z, the square of the distance, P. That's going to be, I'm just going to go ahead and tell you, when you see those words, that's going to be D squared. All right? The square of the blah, 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 P, that would be P squared. Most of the time students will take the square root. Do not do that. So to lessen the confusion, I just highlight this and I tell students when you see the square of the distance, the square of the height, H, the square of the weight, W, you just put W or H or D and you put it to the second power. Everybody with me? Thank you, one person. I appreciate it. Okay, I'm sorry, 2 people. Varies directly. Still 2 out of 15. 13. Well, 2 out of 13. From the projector to the screen, if the projector, okay, just stop. Stop right here. Everything above here is figuring out the what? The formula. So we got y is equal to k times x. That comes from this. The area, what is A going to be? Where are you going to insert A for? Y. Because you read from left to right, and Y comes first, A comes first. So, change on the movie screen varies directly as the square of the what? Distance. So that'd be K times what? D squared. And now you're ready for the second part. So, I want you to do the second part. If a projector at a distance of 25 feet projects a screen at 100 feet, what is the area of projection? This is a type 2 question. Remember, we're telling you 2 types. So you have to write the formula with the new K after you figure out what K is. If a projector is at a distance of what? K 25 squared. And area of what? 100 feet. What do you think they're going to ask you to find? K. So what is 25 squared? 625, isn't it? I think it's 625. Divide both sides by 625, and K is equal to 100 divided by 625. And I'm just going to leave that as 100 over 625 right now. And what are we going to do with 100 over 625 after we find it out? Plug it back into the what? Original equation. So I'm going to take this K, and I'm going to plug it right in here. So A is equal to 100 over 625 times D squared. Now, like I said, you can change that into a smaller fraction. You can change it into a decimal. I don't care, all right? Because all you're going to do at the end is take this 40 feet and plug it in where? Right here, and calculate it with a calculator. So go ahead and do that, because that's part 3. That's the third type question. After you find K and plug it back into the original equation, you do what? You take that more information, this is more info, and what do you do with the more info? You plug it in. So somebody take 40 times 40, which is what, 1,600? And multiply by 100 over 625. You didn't just ask that. You didn't just ask that. Why am I asking her that? No. What did I just tell y'all? You might have been playing on Facebook. Well, whatever you were playing with.
It's a calculator.
No, it wasn't. I said you can make this 100 over 625. You can keep it like this. You can make it a smaller fraction, or you can make it a decimal. Twice. I said it the first time, but you were playing on the phone. Yes, you were. Don't sit there and tell me a story. Okay, well, a while ago when you were playing on your phone, it had something that looked like Facebook. I'm sorry. But you can take it. All right. So what'd you get? What's 100 divided by 65 multiplied by 1600? Okay, I'm waiting. You're going to have to interact. Some of y'all with calculators, you're going to have to interact. I'm sorry, what? 256. So the area of the screen is 256 square feet. So 256, whatever you came out with, feet. And that's the type problems you're going to see on the test. How many? Probably one or two. Right. I mean, you don't have to, because they have all the, they're just going to ask for the number. Okay? So this one is a type 3 question. And it asks you it tells you, it gives you the stuff for the formula, then it tells you to put K back in, and then it tells you to figure with more info. All right, let's try nerd. Now let's see what else they have for us. Okay. Okay, it's come out in 0.16. 40, okay, there you go, 2.6. I didn't know these things actually did that. This is the first time I used these, I think. I haven't used them before. All right, here's an inverse. Let's see. All right, the loudness. The loudness L of a stereo speaker, measured in decibels, you don't know about that, varies inversely as the square of the distance. What I say square of the distance meant? D to the second power, yes. Thank you for the interaction, I appreciate that. 3 people, 4 people. Appreciate the 4 people interacting out of 13. What time's class over? Okay, we're going to finish in 5 minutes because I got to do the video and people beat down the door when they come in. Teacher should see about 15 minutes. What is today? Is today biology? Why? Oh, good. Thank you. Huh? Well, the teacher should have been here like 5 minutes before class. 5 minutes before my class, and I'm like, are you early? And I've already dropped her a couple of hints, trying to be nice.
You're nice.
Yeah, exactly. And she keeps coming in earlier, and I'm like, okay, well, you can just sit and wait. Let's go. Loudness, so that'd be L is equal to what? I'm going to put a big L. So you won't think that's a 1. Big L is equal to what? K over what? And this one is D squared. So that takes care of all of that. And then they say if the loudness is 20, loudness, L. When the listener is what? 6 feet from the whatever. So what is K? Well, K is going to equal 20 times 36? Well, that's easy, because 36 times 10 is 360, 360 times 2 is 720. So 720 is equal to K. And what are we going to do with that 720? Plug it back in, and that gives me L is equal to 720 over D squared. So that's part 2. Part 1 was actually finding K. This is part 1. That's part 1. And part 2 is right there. So that takes care of this. Then what's left? Okay, well, they're done. Now, this part is where they would put more info. They would say, determine the equation or determine the loudness if a person was to be 50 feet from the speaker. Then if that was the case, you'd be L equals 720 over 50 raised to the what? Second positive. They don't give us that, but I'm just saying, if there was more information, it would be after this comma right here. It would say, determine the decibels or loudness if a person wants to be 50 feet away from the, and that's the test questions I'm going to give you. Okay? No comment? Of course not in this class. Yeah. Appreciate y'all's interaction. It really helps out, makes class go by quicker.